Hello everyone, welcome. Hope you're having a good day. We're going to get started looking at the Quizizz activity for 3.1. So once you log in, you should see a little box here. Make sure you're typing your name in, and then you can hit start. So this Quizizz is a little different. It's not all questions. There's also some it's called a presentation. So there's like some lesson notes and then there's questions built in as well. So we're going to kind of go through the presentation and then answer questions throughout, kind of like an ed puzzle, okay? So this is slope and rate of change lesson. For finding the slope, we're finding the rate of change. If something is not linear, then the slope changes. So we find certain rates of change between two specific points. You may recall this YouTube video of Slope Dude. Slope Dude kind of just goes over and teaches you the 4 different types of slope that we have. When you are going uphill, right, it is a positive slope. So it's hard to go uphill on skis or even walking uphill. So that's puff, puff, positive. And then if we're going downhill, it was nice, negative, right? Just cruising downhill. If we're flat, horizontal, that slope is 0. This is 0 fun. And then of course, if we have our vertical line, it's undefined. And those are our 4 types of slope. Just to show you, in the bottom right corner, there are these arrows you can use to flip through the slides. So positive goes up from left to right. Negative goes down from left to right. 0 slope is no vertical change. It is only a flat horizontal. And undefined is a vertical line. There's no horizontal change. It is just going up and down. Push ahead to slide 3. Feel free to take any notes on your own if you want. If you find these graphics helpful, feel free to take a screenshot, whatever you need to support you. Now, when we're looking at slope on a graph, as we did in our pear deck and in our that quiz, we're always thinking of our rise over run. We really want to drill that into our head, rise over run, rise over run. And then remember that our rise is the vertical change, right? It's the y2 minus y1. It's our change in our y coordinates. It's how much we're going up or down. And the run is our x coordinates. X-axis goes left to right. So if we want to find the run, we're looking at those x coordinates. That is our change in x, and we call that our run, okay? When you're all set here, you can push ahead to the next slide. So to think about 0 and undefined slope, horizontal lines have no vertical change. They are not going up or down. They're only going left and right. So the rise is always 0. And 0 divided by any number is always going to be 0. So that's why our horizontal lines have 0 slope. Vertical lines have no run. They only go up and down. So it'll be some number over a 0, because our run is 0. But we cannot divide by 0. So because of that, then we have to plug in, that's an undefined slope. All right, so in that bottom right corner, you can go to the next slide. So this question's asking for the slope of the line. And when we're working through this, again, we're always thinking of our rise over run, okay? So we see 2 points that are given to us. Our rise is the vertical change, how much we're going up. 2, 3, because we went up from a 1 to a 4. And then our horizontal change is going over from a 0 to a 2. So we went to the right 2. So our rise is 3 and our run is 2. So we have a slope of a positive 3/2. We're going to select that option, and then it'll bring us to the next question. Here we go. Slope of this line. So we have our vertical slope here. If we think about it in terms of rise over run, we can pick 2 points. Between these 2 points, our rise is 3, and there is no run. This is our bad, can't divide by 0. This is our undefined slope. Beautiful. Next question, slope of this line. Any 2 points that you choose will get you the slope. If you choose points that are further away, you may have to reduce the slope. So let's choose further away points just to show you. So this furthest point with this point, making my little slope triangle, I see us going up 3 and over 5, 6. So our rise over run is 3 over 6. Notice we don't see that as an option here. So what we need to do is we need to reduce this fraction. So a number that goes into 3 and goes into 6 is 3. So we can divide both numbers by 3 to reduce the fraction. 3 divided by 3 is 1. 6 divided by 3 is 2. So we do have a slope of 1/2, right? We're going up 1 over 2. So that's just our reduced fraction for the slope. Select that, and we'll go to the next slide. What is the slope of this line? This is our flat horizontal line. If we were to pick 2 points, we could find a run, but we have no rise. It is not going up or down, so our slope is just 0. Beautiful. We can also find slope from a table. So to do that, you want to find the change in y, that is our rise, and divide it by the change in x, which is our run. So we have our change in y, that's on top, and we get that from our y values. Notice the change, if it's linear, will be the same each time, just like those arithmetic sequences. And the change in x on the other side, we see from the table, those are going up by 2 each time. So they just wrote this fraction as, okay, we went down 4 and over 2. -4 divided by 2 is a -2 as our final slope. Let's go to the next one. So what is the slope shown in this table? So we want to think of our rise over run. So our rise is that change in y. How are we going from 2 to -2? We're getting lower, it's getting smaller. We're going down 4. So our rise is -4. Our x value is going from 9 to 3. So it's also getting smaller, it's going down 6. So we have -4 over -6. We can reduce that fraction. We can divide both of those numbers by 2. -4 divided by 2 is -2. -6 divided by 2 is -3. Since we have 2 negative signs here, those will cancel each other out, and this just gives us a slope of 2/3. So we reduced it, then we got rid of those negatives because there was 2 negatives to make us a positive. Beautiful. The slope from the table here, we're going from 7 to -4. So here the numbers are actually getting bigger. They're getting closer to 0, and then they're getting positive. So we're going up 3. We could also see that by looking at our positive numbers if negatives are tricky for us. And our x's are going up by 1. So our rise over run, we are going up 3 and over 1. And we can just simplify that as 3, a positive 3. Beautiful. What is the slope shown on the table? Make sure to simplify. So how do we get from 14 to 8? Those numbers are getting smaller. We're going down 6. Yeah, beautiful. And then from -4 to -2, they're actually getting bigger, closer to 0. We're going up 2. So our rise is -6 and our run is 2. -6 divided by 2 gets us a value of -3. So I'm going to plug -3 in for our slope. Beautiful. Another way that we can find slope, so we can do it, or average rate of change from a graph, from a table, and now we can do it using just 2 ordered pairs. So when we do this, we use what's called the slope formula, which we looked at in the pair deck. So we subtract our y's on top, that's our rise, and then we divided it by our subtracted x's. A key part of this is make sure that you are labeling your points. Remember, points are always x comma y, so x is always in the front and then y, and we just label them as x1, y1 for the first point and x2, y2 for the second point. It doesn't matter which point is the x1, y1 or the x2, y2, but to order them, it's important so we make sure that we're subtracting in the same order. Okay, let's take a look at an example. So our first point here is 3, -4. So I'm just going to label that as x1, y1. And our second point is -1, 6. And that's our x2, y2. Now we're taking these points and plugging them in to our slope formula, which is subtracting the y's divided by subtracting the x's. y2 minus y1 is 6 minus a -4. Careful with your signs. If you have a negative and you're plugging it in, you are going to get that double negative. -1 is our x2 minus 3. When we get this double negative, that becomes a plus. So we have 6 plus 4, which is 10, divided by -1 minus 3 is -4. We don't see that as an option, so let's try to reduce. So 10 over -4. We can divide both of these numbers by 2. They're both even. And then we get 5 over -2 for our final answer. Beautiful. Slope / rate of change in word problems. So here's some examples of where we'll be able to pull slope or rate of change out of information that's given to us. Marcy travels 65 miles per hour, right? Per. Daniel earns $14 per hour. Sheila bakes 3 cookies per person. Ground beef costs $4.50. Oops, wrong one. Per pound. So whenever we see per, it's telling us about a rate of change that's happening. We could also see something like each hack costs $14 or car rental is $50 a day. When we're having this rate of change given to us, it's a clue that we can find the rate of change between these points and find that average rate of change. Let's look at the next slide. I'm about to run out of time, so I'm going to pause it here and there's just a little tiny bit left that we're going to do in part 2. So take a second to pause and we'll look at the next one in a moment.